Now let us discuss the types of chemical bonds. So the first type of chemical bond is ionic bond, and it is also called electrovalent bond. Ionic bond or electrovalent bond. This ionic bond involves transfer of one or more electrons. If there is transfer of electrons, then that bond is going to be ionic bond. So we have example of ionic bond such as sodium chloride, calcium oxide. So let us look at it, how the sodium chloride is formed by transferring of electron. So sodium chloride. Sodium, we all know that it has atomic number of 11. Chlorine, it has atomic number of 70. And the electronic configuration for sodium is 2, 8, 1. And electronic configuration for chlorine is 2, 8, 7. So if you notice, the valence electron for sodium and chlorine, they have 1 and 7 respectively, and they are not stable since they will follow octet rule. So sodium need to acquire 8 valence electron, chlorine need to acquire 8 valence electron to become stable. How will sodium acquire 8 electrons? So if the sodium loses the 1 valence electron, so it will be left with only 2 and 8, and the valence electron is 8. So it will become stable. So sodium here is going to lose its 1 electron. And chlorine, since it has 8 valence electron, so how will it become stable? So by gaining the 1 electron lost by the sodium, it will become, the valence electron will become 8. So to understand this, let me just draw the atomic structure for sodium and chlorine first. Sodium is nucleus, first shell, since there are 3 shells, second shell, and then third shell. So first shell contain 2 electrons, shell have 8, so 8 dots, 1, 2, 3, 4, 5, 6, 7, and 8. And the last shell will contain only 1 electron. Then we have the chlorine atom. So even chlorine, it have 3 shells. So 1, 2, and 3. So first shell contain 2 electrons. Second shell 8 electrons. And the third shell contain only 7. So 1, 2, 3, 4, 5, 6, and then 7 electrons. So let us say that this blue color represents the 1 valence electron of sodium atom. So to become stable, sodium is going to lose its 1 electron to chlorine. So sodium here is losing 1 electron and chlorine is going to gain 1 electron. So what will be the final state? Now it will only contain 2 shells. The first shell will contain 2 electrons, 1, 2. Second shell will contain 8, 1, 2, 3, 4, 5, 6, 7, and 8. Now let me draw the chlorine atom. So chlorine atom, the first shell carries 2 electrons, second shell carries 8 electrons, and the third shell will hold 8 electrons. The last electron, it came from sodium. So since sodium lost 1 electron, it will bear 1 positive charge. Chlorine, since it gained 1 electron, it will gain positive charge. So this is called ionic bond. Now second type of chemical bond is covalent bond. Ionic bond involves transfer of electron. Covalent bond It involves sharing of electrons. So if there is sharing of electrons, that bond is called covalent bond. Examples we have already looked at it, that is hydrogen, H2 molecule, and another one is carbon dioxide molecule. So let me just draw the structure for carbon dioxide to understand the covalent bond. So CO2, 1 carbon, 2 oxygen atom. So carbon atomic number is 6, oxygen's atomic number is 8, and its electron configuration for carbon is 2, 4. For oxygen it is 2, 6. If you look at the valence electron, carbon have only 4 and oxygen have only 6. So to become stable, carbon need to gain 4 more electrons to become octet state. Oxygen need to gain only 2 electrons. To explain this, let me just draw its structure. So we have one carbon atom with 2 shells, 2 shells. The first shell contains 2 electrons, second shell contains 4. 1, 2, 3, 4. Now let me draw the oxygen atom first. Now there are 2 oxygen atoms who is going to share 2 electrons each to become stable. So since oxygen have 2 shells, so last shell is going to overlap with the carbon atom. So this overlap indicates they are sharing electron. So if you see overlap of shell, that means they are sharing electrons. So first shell contains 2 electrons, second shell contains 6. So 1, 2, 3, 4, 5, and 6. Now another oxygen atom also contains 2 shells. Here also the valence shell is going to overlap. So let me highlight the electrons shared by oxygen atom with the blue color. So this 2 electrons is shared by the first oxygen atom, and another one 2 electrons is shared by the second oxygen atom. So here the carbon and oxygen atom, they have acquired octet state to become stable. So this is called covalent bond. That type of bond is called coordinate bond, and it is also called as dative bond. So this coordinate bond involves sharing of electrons, but the condition is the shared electron, which is also called shared pair, is only contributed by one atom. The new term here is shared pair. So what does shared pair of electron means? It is the electron that are shared between the atoms. So in coordinate bond, the shared pair of electron is contributed by only one atom. That type of bond is called coordinate bond. So example we have here is hydronium ion and ammonium ion. Look at the structure of hydronium ion to understand coordinate bond. So the formula of hydronium ion is H3O plus ion. So we have 3 hydrogen here and 1 oxygen atom. So the electronic configuration for hydrogen is 1 and electronic configuration for oxygen is 2, 6. Before we start drawing the electrons, for hydrogen I'm going to represent the electron with a dot, and for oxygen I'm going to represent the electron with cross. So this type of representation is called Lewis structure. So if you represent one of the atom's electron with dot and another atom's electron with cross, that structure is called Lewis structure, or it is also called electron dot structure. So let's draw the atomic structure of oxygen first. So we have oxygen O, and the first shell contains 2 electrons. So here we are going to represent the electron of oxygen with a cross. And the second shell contains 6 electrons. So 1, 2, 3, 4, 5, 6. Now let me draw the 3 hydrogens atom here. So the first hydrogen atom will share its 1 electron with the oxygen atom, and the electron here the electron is represented with a dot. So the second hydrogen, again it's going to share its 1 electron with oxygen and it's represented with a dot. So if you count the valence electron of hydrogen, you will find that it has 2. And here also 2. So hydrogen, as we already know, that it will follow duplet configuration, whereas the oxygen, it only needs 2 electrons to complete the octet. So if you count the electrons in the valence shell of oxygen, you will find 8. So let us count it together. 1, 2, 3, 4, 5, 6, 7, and 8. Now we are left with again one more hydrogen. But this time, this hydrogen does not contain any electron, meaning this hydrogen, it has already lost its 1 electron, so it is going to receive the shared pair, a pair of electron from oxygen. So for this reason, I'm going to overlap the hydrogen's shell over the oxygen shell. Now if you count the valence electron of this new hydrogen, you'll find that it is 2. So all of these are stable. This shared pair of electron that you see here is known as coordinate bond. If I simplify the structure here, so we have the one oxygen atom here, then another hydrogen atom, and the last hydrogen atom here. So between the first hydrogen and oxygen, we only see a covalent bond. And the covalent bond here is indicated with a single line. So another covalent bond here. And the last one here is represented with an arrow. So this arrow represents coordinate bond. So this bond is covalent bond. And the arrow that you see here is coordinate bond. So also remember that coordinate bond is represented with an arrow. Now the activity. So I want all the students to try to write the Lewis symbol or the Lewis structure for oxygen molecule and magnesium oxide molecule. So always remember to write the symbol of any element first, and after that do not forget to write its atomic number, so that it will help you to write electronic configuration, and from electronic configuration you will get to know its valence electron, and from valence electron you will get the hint that whether it need to attain octet state or duplet state. So from there you will be able to understand whether they are going to share electron or transfer electron. We have discussed the definition of chemical bonding, and also we have discussed the reason why they undergo chemical bonding, and the 3 types of bonds, and the activities that you have to do it as your homework. So with this, we're done.